Every day, this plant pulls millions of liters of ocean water from the sea and turns it into something that keeps cities alive. The ocean holds 97% of all water on Earth. Almost none of it is drinkable. That is the problem this machine exists to solve. Start here. One molecule, surrounded by thousands of dissolved salt crystals. This is what seawater looks like from the inside. That single molecule will travel through one of the most sophisticated industrial processes ever built. This is its journey. The first step is entry. Millions of cubic meters of seawater are drawn through these intake channels every single day. Beneath the surface, the plant is already working, pulling, drawing, consuming the ocean at a rate most people cannot imagine. The first barrier. Rotating screens strip out seaweed, fish, and debris before anything enters the treatment process. Inside the intake pipe, the water is moving fast, very fast. Enough flow to fill an Olympic swimming pool every 4 minutes. Everything converges here. Pipes from across the intake field merge into a single unstoppable river of raw seawater. Seen from above, the pre-treatment complex looks almost mathematical. 6 settling basins arranged in perfect geometric order. Raw seawater is not just salty. It carries sand, algae, clay, and microscopic organic material invisible to the naked eye. A precise dose of coagulant chemical is injected here. What happens next is chemistry working at a scale too small to see. The coagulant carries an electrical charge. It attracts particles, pulls them together, forces them to become something heavier than water. Inside the clarifier, gravity does the work. Heavier flock particles sink slowly downward, leaving clearer water above. Watch the water itself. Rising through the clarifier, it changes. The turbidity that entered at the bottom never reaches the top. The filtration hall. Hundreds of pressure vessels, each one packed with layers of sand and anthracite coal, waiting for the water. 3 distinct layers. Each one captures what the last one missed. Physical filtration, removing what chemistry alone cannot. The plant measures everything: pressure, flow, turbidity. Every sensor feeds data to a system that never sleeps and never stops watching. Here is where the real power lives. The high-pressure pump hall. Enough electricity to power a small town, directed at a single purpose. These pumps will build pressure to 800 pounds per square inch. That force is what makes everything that follows possible. 800 psi. That is 55 times the pressure of the atmosphere at sea level. Enough force to push water through the impossible. The gauge climbs. 600, 700, 800. At this pressure, seawater becomes something else entirely. A driven projectile. Inside the pipe, the water is no longer moving gently. It is accelerating, compressed, forced forward by mechanical power. The pipe gallery leads here. The reverse osmosis membrane hall. The place where salt and water are finally separated. 3,000 pressure vessels, each one containing a membrane so fine it blocks a sodium ion but allows a water molecule through. Inside each vessel, a spiral wound membrane element, the technology that makes desalination possible at industrial scale. The membrane is a thin film composite, 3 layers, 200 microns thick, thinner than a human hair, more selective than any filter in nature. Zoom in far enough and the membrane surface becomes a landscape, a polymer terrain that water molecules must navigate molecule by molecule. At this scale, the seawater looks crowded. Sodium ions, chloride ions, water molecules, all moving together under extreme pressure. The membrane allows only one thing through. A water molecule is 0.28 nanometers in diameter. A hydrated sodium ion is larger. That difference is everything. One molecule finds a transient gap in the polymer network, diffuses through, crosses from the salt side to the pure side. On the other side of the membrane, there is no salt, no ions, only water. Pure, clean, drinkable water emerging one molecule at a time. Multiply that by billions, trillions, happening simultaneously across 3,000 membrane vessels. That is how you make a city's water supply. The permeate channel fills. Molecule by molecule, stream by stream, the pure water accumulates, the product of an impossible molecular selection. What the membrane rejects becomes brine. The salt from 1 liter now concentrated into half, twice as salty as the ocean. Two streams emerge from one inlet, blue for permeate, red for concentrate. The same water, now permanently separated by what a membrane decided. Millions of individual molecular crossings, adding up to hundreds of thousands of liters of pure water per hour. The brine stream still carries enormous hydraulic pressure. Releasing it as waste would be criminal, so the plant captures it. The isobaric pressure exchanger. High-pressure brine enters one side. Its energy is transferred, without pumping, directly into the incoming seawater feed. 98% of that pressure is recovered. The energy that desalination once wasted is now the energy that drives it forward. Where recovery demands more force, a Pelton turbine spins in the brine jet stream, recovering the remaining kinetic energy as electricity. Energy recovered, energy reused. A desalination plant that powered itself partly from its own waste. This is what modern engineering looks like. The solar field feeds clean electrons directly into the plant's grid. Sun-powered pumps, sun-powered membranes. The future of water is renewable. The substation steps the voltage down. The power moves underground. Unseen, unheard, but present in every liter of water this plant produces. 150 microsiemens per centimeter. That is the conductivity of the permeate leaving the membrane system. Almost no ions remain. The plant has no shift supervisor standing over it. The SCADA system monitors every sensor, every valve, every pump, autonomously, continuously, without error. A single instrument confirms what the process promised. The numbers do not lie. The molecule crossed successfully. The salt stayed behind. In the laboratory, a beam of light passes through the permeate sample without scattering. Near perfect optical clarity. The signature of ultra-pure water. At the molecular level, the permeate world is silent. No sodium, no chloride. Just water molecules, finally alone, moving freely together. Now the plant does something counterintuitive. It adds minerals back. Calcium, bicarbonate, because water too pure for ions is too corrosive for pipes. The remineralization system restores just enough chemistry to make the water stable, palatable, and safe for the infrastructure it will travel through. Ultraviolet light floods the reactor chamber. Any microorganism that survived the membrane and the chemistry is rendered non-viable here. Physics as a final weapon. A chloramine dose is introduced, not to purify, the water is already pure, but to protect it across the kilometers of pipes still ahead. The finished water pumping station, the last major machinery the water will encounter before it disappears into the city beneath the ground. pH 7.6, turbidity 0.03 NTU, chlorine residual 0.5 milligrams per liter, every number in range. The molecule has passed every test. 500 million liters held in stillness. The cumulative product of one plant operating continuously for days. A reservoir of manufactured survival. One last look through the water itself from below. Nothing distorts the view. Nothing scatters the light. This is what absence of contamination looks like. The transmission main runs from the coast to the city. Kilometers of buried pipe carrying the ocean's water, stripped of its salt, across the desert. Beneath the street grid, the molecule navigates a branching pipe network, trunk main, distribution main, service line, to a single home. The journey ends here. Ocean salt water, arrived as a droplet of drinking water, 800 kilometers of pipe, 140 process steps, one molecule. Across the desert, the transmission line carries what the coast makes to where people live. Water flowing uphill against geography because of engineering. The hidden city. Beneath every road, a water system as complex as the one above. The molecule travels through it unseen, in the dark. Before dawn, the storage towers hold pressure constant across the distribution network. The city sleeps. The water system does not. This is the end of the industrial chain. A kitchen tap. Desalinated water 3 seconds from the ocean via the most complex process on the planet. The same molecule. Before and after. Measured in parts per million. The difference between survival and thirst. 5 million people live in this city. The ocean surrounds them on one side, the desert on the other. Between them and thirst, one plant. Step back far enough and you see it all. The ocean, the plant, the desert, the city. Engineering connecting water to life. The plant never sleeps. While the city rests, the membranes separate, the pumps drive, the molecules cross. Water made in the dark. The dry lake bed became a city because someone built a pipe from the sea and found a way to remove the salt. The sun rises over the solar field. Panels angle toward the light. Electrons flow. Pumps spin. Sunlight becomes drinking water. A glass filling with desalinated water. This is what 3,000 pressure vessels, 800 psi, and a membrane thinner than a hair produces. This, from ocean wave to this glass. It happened. It is happening now. On every inhabited coastline, the ocean becoming something we can drink. The sun rises again over the intake towers. Yesterday's ocean is this morning's water supply. The machine never stopped. It never will. The ocean is still there. Endless, unchanged. And the glass is full. That is how engineering decided water scarcity was a problem it could solve.